Stacks have various applications in computer science and software development due to their LIFO, last in first out, nature. Here are some common applications of stacks. 1. Function call stack. Stacks are extensively used in programming languages to manage function calls and execution. Whenever a function is called, its local variables and execution context are pushed onto the stack, and when the function returns, the stack is popped to restore the previous context. This stack of function calls is known as the call stack or execution stack. 2. Expression evaluation. Stacks are used in the evaluation of expressions, especially arithmetic expressions. When an expression is evaluated, it is often converted into postfix notation, also known as reverse Polish notation, to simplify the evaluation process. A stack is used to store operators temporarily and compute the result based on the operands. 3. Undo-redo functionality. Stacks are utilized in implementing the undo and redo operations in many applications, such as text editors, image editing software, and drawing tools. Each operation performed by the user is pushed onto the stack, allowing them to revert the changes by popping the stack, undo, or reapplying them, redo. 4. Browser history. Web browsers use stacks to maintain the history of visited web pages. Each time a user visits a new page, the URL of that page is pushed onto the stack. The user can then navigate backward by popping the stack to access previously visited pages. 5. Backtracking algorithms. Backtracking algorithms, such as depth-first search, DFS, often use stacks to store the state of the exploration. The stack holds the choices made at each step, and if the current path does not lead to the desired solution, the algorithm backtracks by popping the stack and trying an alternative path. 6. Parsing and syntax analysis. Stacks are vital in parsing and syntax analysis of programming languages. They help in checking the correctness of expressions, verifying the proper closing of brackets, and detecting syntax errors. The stack is used to track opening and closing symbols, ensuring they match in a balanced manner. 7. Compiler and interpreter design. Stacks play a crucial role in the implementation of compilers and interpreters. They are used to store variables, temporary values, and return addresses during the translation or execution process. The call stack is used to manage function calls and parameter passing. 8. Memory management. Stacks are used for memory management in many programming languages. Local variables, function parameters, and return addresses are typically stored on the stack. Stack frames are allocated and deallocated as functions are called and returned, allowing efficient memory usage. These are just a few examples of how stacks are used in various applications. Stacks provide an intuitive and efficient way to manage data and control flow, making them a fundamental data structure in computer science.